Hello, everyone, and thank you for making this session, despite it being the last one of the day and of the event. So I really appreciate you joining us today. My name is Hayes-Thakore, and I'm VP of Marketing at Kigen. And some of you, and I was sort of walking the floor, have learned that know me from hosting the bi-monthly Kigen Future of Sim conversations on webinars. So it is a real delight to actually have you all join us today for a live session. So thank you for the opportunity to Hardware Pioneers Max for having this in-person Future of Sim conversation. And I'm really hoping that today's session will be a fast-paced, future-focused and straight-talking, kind of light-hearted but sharp conversation about where connected products are really heading. And it's all about cellular connectivity for this session. So for the eagle-eyed of you, this event is about 35% product offering that is cellular. But if you come to the sessions that have been taking place at this and the other track, about 45-50% of the talks have at least included an element of cellular, and just sort of shows a little bit from my very selfish view that that's where things are heating up and that really things are changing in cellular world. And today we'll give you a snippet of that. So I'm really, really delighted to be joined by some of the sharpest minds in the industry that are not only just living these changes, but really helping shape them for the greater industry. So thank you to my panel already. We've called this session Satellites, Silicon and Security Walk into a Bar. And I'm hoping I'll stay around for your punchlines later too, but you can tell me. But really, it's because these three things are really changing cellular connectivity, cellular hardware as we've known it. So connected product design used to mean long lead times, complex logistics, and patchwork strategies just to get devices online. And that is changing. That's the big kind of message to take away from today if you don't already know that. But we will peel away why that is relevant to you now. And whether that's the shift from traditional SIMs to eSIM and iSIM, the rise of satellite connectivity, or AI moving in decision-making all the way to the edge and to the device itself, we're looking at a complete rethink of how we build, how we ship, and how we scale connected hardware. And beyond this tech, really, this conversation is about ambition, about where you want to take your connected products to global scale. That's where ecosystems like the one convening here really matters in giving you a strategic edge. So let's keep it controversial, conversational, a little provocative if possible, but very, very real. And to kick things off, I've got a little video to show you because we made it and, it's nice to see. But after that, maybe I'll invite back my panel to introduce themselves. So, please, would you introduce yourself, starting from Vincent?
Sure. Can you hear me? So my name is Vincent Korstanje. I am the CEO of Kigen. I have been on a journey for IoT probably for the last 15 years, and I'm really excited to talk today about some of the new things we're seeing in IoT, as well as how we're dealing with security.
Hi, I'm Georgia Cooke. I'm a research analyst with ABI Research covering cellular security and eSIM topics, and the author of a white paper we're going to touch on later, developed in collaboration with Kigen. And again, excited to talk to you about security.
And my name's Simon Glassman. I head up business development at Skylo. And for those of you that don't know, Skylo is a direct-to-device satellite provider addressing IoT, consumer and automotive markets. And yeah, like these guys, I've been in the industry for quite a while.
Well, welcome everyone. Thank you for joining. And let me begin by asking our panel something I've heard here a lot of hardware teams wondering about at the moment. Now, it feels like the ground has clearly shifted under our feet. Things have moved on in connectivity, in security, and in silicon. And scale is a whole new game now. So let's start here. If you were building a connected product today that must scale globally, what's the first thing you'll do differently that you wouldn't have done 5 years ago? Do you want to start and we'll walk through this one?
So I think it's really important when you bring a product worldwide is to have interplay between the different components. So when we introduced eSIM probably about 10 years ago, it was very focused on one provider working with their device maker. And that was okay, but it was called the M2M standard. And the M2M standard now was very innovative, but given time, actually, it didn't work as well as the new consumer standards. Now, we all use eSIM for consumer. When you travel, you can download your package and it just works all over the world. Now, M2M doesn't quite work that way. So we've been innovating together with the GSMA in something called the IoT eSIM standard, or the SGP32, for those who are keen about the acronyms. And that effectively works very similar to the consumer standard, that it works with every supplier all over the world, very simply. But it's a little different than the consumer, because consumer, you have a person actually pressing the little interface. You might not have it with IoT. It's more fleet management, but that's a real new standard that's just coming out. And really now engages with different suppliers, and it works all the same across the world. So if you're designing for the world, this is a really important step to do now. Georgia.
Fantastic.
I would add along those lines, it's starting from that point. It's starting from a compliant solution and starting from those standards so that you have that potential for automation as you need to scale. You don't have to overhaul any part of your system. You just have to introduce more capacity.
And Simon?
Yeah, I think trying to think back now, over 5 years and what may be done differently. I was previously with a module manufacturer.
Yeah, very much in the heart of connected hardware. Absolutely.
It's a good question. Maybe 3 things. I think the first is think about your connectivity choice. When you're developing a device, which technologies, radio access technology, it needs to support, because you think back to all the hype and all the momentum around, for example, low power wide area technologies, which are still valid, like narrowband IoT and LTM. Yes, they're there, but they're not fully ubiquitous. And we're seeing some shifts today. For example, LTE Cat 1, BIS, it's available globally everywhere. It's simple, it's 4G, and the price points are kind of suitable. So you have to think about that, because you have to select your module and chipset, etc., and do all the certification testing, blah, blah, blah.
Right.
And the other dimension, of course, I will say, is satellite, which wasn't something that was commercially viable, half a decade ago.
Oh, yeah.
I think the second thing beyond the connectivity choice is maybe security. And I think in summary, that isn't something that should be considered as an afterthought or a bolt-on, but something that's kind of designed in from the outset, because as IoT as a market scales and, all the hockey sticks go, 50 billion devices, the probability of something perhaps going wrong, or there being some kind of malware or an attack, interface being jeopardized or whatever, the probability goes up. So security is important. And I think the third thing is absolutely around eSIM and iSIM, because the SIM is becoming much more closely coupled to the core device and hardware. It's not just an external a bit of plastic anymore.
Yeah, absolutely. Sort of about 5 years ago, people would have considered some of the newer at the time low power wide area networks, but it has always been sort of a little bit harder to get these devices to truly kind of build in one place and then globally connect. And that there are a lot more choices. There are also so many examples of devices which have had, from an IoT point of view, iterations in terms of what should be avoided for kind of your brand in terms of making sure security is right from the very get-go. So I think those are excellent points, and I think maybe I'll come back to the point you made around satellite, particularly NTN. Now, that was not around as viable 5 years ago. It was very much kind of seen as something that was probably for just the very remote outposts, or potentially, I think there is also a question at the moment, where are we in the journey? Is it really for some exotic use cases, or is it really coming towards the more mainstream connectivity? That happens for you to start with.
I mean, satellite itself as a technology for communication has been around for a long time, but I think the key difference between back then and now is it was generally proprietary.
Yeah.
So all the implementations, whether from the device up to the mirror in the sky, have been essentially proprietary. Whereas now, because NTN, non-terrestrial communications, is directly supported within the mobile standards, it's almost as though it's kind of business as usual. Right. So it makes it much easier to scale. So whether that's at the device end, because you only need to add a bit of firmware into an existing cellular device to make it work on NTN, how a company like Skylo interfaces or integrates our network to a mobile operator, we look like just another roaming partner. So it's kind of simplified that process. But yeah, obviously in terms of the commercial aspect, it's still much, it's more highly priced, but then it depends. It's all around the criticality of the application, because, I mean, to your point, you may be in a place where there's no cellular coverage, which is 80% of the planet, 85% of the planet doesn't have cellular coverage. So there may be instances where, the price isn't, the main driver. So I see it more as a complementary,
so it's
technology
where
rather
people need to recognize it as a commercial strategic advantage to mission critical connectivity.
Yeah, but I think also, even smartphones, we see it today now, it's coming in not just on IoT, but as a backup to cellular when you're out of coverage, and SOS, emergency services, those kind of things. I mean, it will become the norm, I think, in the not too distant future.
And I think this is a really interesting part, because this has also been possible with standardization, right? It's where connected hardware manufacturers already have a lot of headaches to solve. How does standardization kind of support, better design, better ability to kind of make these kind of buy or build decisions? Vincent, you've been kind of, at least driving the journey towards standardization for a very long time, and how that helps connected hardware. What's changing, and we got a little preview in the video, but what's changing around, the greater choices in the standards? What should people be aware of around this journey for standards making cellular easier?
Yeah, I think that's quite important now. When you think about cellular, it's very powerful. I love the Skylo use case, right? You're effectively just roaming onto a satellite network. You're coming, say you are shipping products, you're tracking products from Shanghai to Rotterdam. You're on the boat, you're connected to China Mobile, and then you roam onto the ocean. You roam onto the satellite, and then in Rotterdam you roam back. So that is possible, and it just works seamlessly because of the standards. Now, when you think about cellular, there's a lot of things that are easier as cellular. As a consumer, when I have a device, it just works. I was talking to a washing machine manufacturer. I've managed it a few times, and they had a Wi-Fi module, $5 in their washing machine, but nobody was connecting their washing machine to the Wi-Fi, because as a consumer, it doesn't really help us. We still have to put in the load in the washing machine, but as a producer, he really likes that, right? Because he wants to get the data off the washing machine. So he was looking at cellular. This was about 10 years ago. There were $30 modem, so that was not quite good. But now we're getting towards that not quite, but that $5 replacement of Wi-Fi, and then it becomes much easier for a consumer. Us as producers, not that easy. Actually, cellular is quite tricky. You have to get a lot of certifications, you get a lot of products done, and this is where it becomes really important to drive the standards. So we've been driving the new IoT standard really hard. We're also driving very hard to things like now, how do you integrate into a supply chain? Integrating into a supply chain, now you can create a device and immediately put some connectivity on it. But actually this device might go anywhere in the world. So now you have a SKU problem. So how do you manage the skew problem? How do you make sure that you can actually update the device to really late moment in your supply chain? Yes, you might do it online, but maybe the online connectivity is too much power. So maybe you want to do it in the factory. So we've been doing a lot of innovation in factory automation and factory provisioning, so that you can order a device and that you can reprogram in the factory. Now, when you talk to people that have factories, maybe some of you do, you get 6 seconds to reprogram the device. And actually that is now one part, so you can only have a little bit of information, but then actually if you think about that whole process, if that order happens today, they take it out of the warehouse, they dry the device, the parts in an oven, then they get the information. You probably have about 8 hours that you know which device it is until it goes out to the factory. And if you have a bit of a time zone difference, because the manufacturer I was talking to was in Japan, you might have an hour. So we've been doing a lot of investment that we can actually take an order and ship the order in about 2 minutes, right? Because we have to fit in that hour window. We have to be able to turn that around very quickly, and that means all the way going to the operator, getting the operator details, going to the device, encrypting it, putting that high security on top of it, and that whole supply chain completely automated in 2 minutes. And that's really important. And you can only do that if you base it upon standards and work together in the industry. Sorry, it's a bit of a long answer, but
no, that's perfect, because I think this is it. What it shows is the coupling of the provisions within the standards, as well as kind of this really understanding the problem of what it takes to provision. So it's now within minutes, right? Because when you walk this floor, a lot of people ask us the question saying, cellular design, cellular connectivity, cellular hardware takes a long time to actually procure and provision on your factory floor. Yes.
I would just add that part of that long time is the investigative phase of how this affects your security posture. And as you touched on, having those standards provides a sort of shorthand for that phase. Everyone has a level playing field and an agreed standard for them to meet, and it takes out a lot of the pain.
Absolutely. And these and we have a really interesting case study on this, right? So that actually illustrates some of the work that has now brought this time of weeks, multiple weeks, to just minutes. Do you want to talk about that? And I'd love some commentary from you, Georgia, because you independently reviewed this as part of the white paper exercise as well.
Yeah, the use case is around wearables. So how do you get a wearable to be standalone from the mobile phone? Right, that is a lot of the wearable operators are experimenting with that. They're kind of looking at new use cases of what kind of connectivity do you want to have? What kind of connectivity can you have? It all goes all the way back to also satellite connectivity, so you can see that. But again, to fit into that supply chain, this is where we really get the data. We can't reveal this use case or this supplier yet, but to get that into that supply chain is really important to go into those minutes, to making sure that you can actually get that whole manufacturing line, and you can actually get this worldwide shipped out, because these wearables can be in the US, they can be in Europe, they can be in China, and it all has to work everywhere, right? So that was the thing that's quite interesting, and it takes a mindset shift from the operators, because one of the operators I was talking to probably about a year ago, and they were talking about the fast track program that we were doing together. And their fast track program went from 6 weeks to 3 weeks, right? And that is now fast track in their business process, but it's not fast enough when you're looking at supply chains and trying to make sure you intercept the supply chains and give that flexibility. So it really has to become fully automated to do that. But you're looking for it, Georgia?
Yeah, so you touched on the fact that it has to work everywhere. It also has to work for everyone, and you touched on that flexibility that's needed to make that happen. That's one of the things that really struck me investigating the use case and Kigen's product is, as usual, it's a market with a lot of very differentiated needs and very diverse needs. So you can't come forth with a complete solution. It has to have elements of customizability and that bring your own connectivity piece, so that you can meet everyone with the requirements they have instead of trying to bend their requirements to fit what you're offering.
Absolutely. I think that's a really good segue to the thing I wanted to talk next, which is sort of scaling from prototype to thousands of devices used to mean a lot of chaos, right? Sort of manual SIM swaps and like fragmented fleet management. There is this now automation, the new standards, the improved security, the the global connectivity, that changes the piece, that changes the picture for people like the smartwatch manufacturer you talked about, that is really kind of a hardware pioneer, right? What is that mindset shift that teams need to embrace in terms of automation? Is it working differently? Is it changing any of the factory setup? What is it that they should consider?
Me? Okay. So I think the key thing there is now we're innovating closely to the hardware manufacturers. I think that is now very important to have. It's very important to have those relationships with the hardware manufacturers, because to realize now what doesn't work. And that is where we brought that new SGP32 eSIM standard, because we are finding that they don't just have one supplier; they have multiple suppliers of connectivity, multiple suppliers of hardware. So how do we all kind of bring it together? And that's again innovating around that. And one of the things, the difference between a consumer device versus an industrial device or an IoT device is the fleet management. So one of the things we had to automate was how can you switch 1 million devices from Vodafone to Deutsche Telekom or the other way around? How can you make it automated that if you go from Germany to France, that your connectivity changes? How can you put rules in place? How can you make sure that you manage this fleet? It's called an EIM. It's a remote eSIM management. And this is something that used to be happening at the operator side, but is now very much coming to the device maker side. So how can I manage my fleet of be that 50,000 cars or be it 100,000 smart meters? It's really important to start now using the software interfaces there in a way that is really secure and locked down, because you don't want once you start opening up a device, you need to make sure that you use the latest security standards, the latest assurance standards, to make sure that nobody can take over the device and just do things with it that you don't want. Right? So that's very important to have both those, that flexibility as well as that standard designed in.
Absolutely. And, earlier we talked about, so on this stage just an hour ago, Eben Upton was talking about how Brompton have automated their entire manufacturing flow. I don't know if you've seen this, but over LinkedIn, the new Xiaomi factory sort of preview has been doing the rounds, and it's one where it's fully automated with the ability to produce a smartphone every second. So, got automation that's really, really changing kind of how connected products, connected hardware are being manufactured. But it's so important that not everyone can be a Xiaomi factory. Not everyone can be an OEM that controls their entire supply chain. So it's really important to work with these standards whilst you're looking at that scale where you're going from the early designs to, the tens of thousands of 50,000s of devices, and really take that such that it will scale fully when you're going global. You looked at this from a kind of batch and automated processing point of view as well. So would you like to sort of give us a little view of what you observed, Georgia?
Yeah, so the ability to manage that automation and have that batch provisioning of profiles inherently leaves you in a position to create a more predictive timeline. You're able to, first of all, work on the automation as a result of the batching, but you can preempt your needs. You're not constantly reacting to fluctuation. You can start to model it and actually action the results of that modeling.
And Simon, automation is also coming into more of the kind of, how connectivity providers use it themselves. Is there another mind shift change that they need to embrace?
It kind of depends which hat you wear, but I think, from a standpoint of, say, someone developing chips and modules, in their millions every month, obviously having a process that is optimized, that allows you to, inject a profile at point of manufacture, can help a lot. It helps with SKU management. It helps with inventory, supply chains, as has been discussed already. If it's obviously it's a secure environment, so that helps. I think also in terms of the end device, the fact that you're doing it at the point of manufacture, there's kind of environmental considerations. It's more robust, and for products and use cases, applications, particularly in the wearables market or telehealth and so on, where you really don't want to have a SIM that is a physical SIM that could go wrong, it's really valuable. So being able to kind of bake that in from the outset in your process, and have the kind of philosophy and thought right at the outset to consider those kind of things that you can now do is really valuable. And then the other thing on the connectivity side, obviously, and particularly with the advent of satellite, it's also a skew benefit because you pretty much have ubiquitous coverage, and you can actually reduce, for example, the number of different SKUs that you need to produce for different markets, because you're not necessarily having to work with multiple operators, MNOs or MVNOs in each market just to address their local needs. You can, it's a smaller number. So I think that's a benefit too.
Fantastic. So, oh yes,
I'd just like to add on a very similar vein that you can bake in security posture at the same time as you're baking in those pragmatic considerations. So you have that opportunity to pitch things at the correct level for the use case.
Yep, fantastic. Now we are going to keep time for just a couple of questions from you all, so that it is interactive. But whilst I don't know whether we can get you a mic. If not, please just raise your hand. I will run to you with it. That's all right. I need to get my steps in as well. So before we do that, I will selfishly ask my last question to the panel. And it sort of seems with all of these changes, we're at a little bit of an inflection point. It's so nice to see all the activity out there on the, at this event, and what all has been happening. There is good news in here. But what is the one shift in connected hardware, the design, the scale, the production, that you think is being massively underestimated right now?
Should I go first?
Yeah.
So I think that a lot of people are talking about AI, right? A lot of people are talking about AI, and Gen AI has really woken the world up for AI. As hardware manufacturers, to me, we have a key role to play in when AI becomes sentient. And not sentient in that it becomes standalone, but when it starts sensing the world. Think about all the things that can be automated, all the data, because now the future is all about the values in the data, because that's what's feeding the AI models. Well, that data is coming from sensors that are measuring the temperature of the room, that are seeing where planes are in the sky, and seeing where cars are. And now that is quite huge from a hardware manufacturing point of view, but also it's quite scary, because now one of a logical attack vector, where would you attack a network like that, is exactly at the edge, because at the edge you don't have enough power maybe to do all the right protection. So that's really important to design in some of that security protection. Again, the eSIM is a really hard security module, if you will, or building block, and you can use it for other parts of your system as well. You can bootstrap your whole security in the eSIM, not only from a connectivity point of view, but also from a device point of view. So I think that's going to be massive. It's going to, as those sensor networks are going to be bound into AI, and that will effectively drive some of the decisions we have in the world.
I'd absolutely echo that point. And I think if we can describe that as a challenge regarding maybe too much data, I think there are also elements of challenge around not enough. Particularly in a more collaborative environment, particularly where supply chains are becoming more complex. We have standards, we have certifications, and they provide a shorthand that help. But there is nonetheless a more complex ecosystem that's developing, and there needs to be the correct data flow to secure that holistically.
So yeah, the relevancy of the data, the availability of that data. Simon, any kind of observations around what's being underestimated right now?
No, I think a double echo, because I think I also would have gone with the Edge AI story. I think it's I know there's a lot of hype about it, but actually I think we're actually starting to see it manifest itself in reality. I was in one of the sessions earlier, and Grin I think presented, I think it was for the disaster wildfire scenario, where they had a sensor that could detect when there was a wildfire starting to come up, but they didn't have to have a video camera pointed at a forest, seeing if there were flames. They could detect certain anomalies and things that shouldn't have happened, and just transmit the delta, the difference. And so you can actually have applications that maybe in the past historically would have required quite a lot of data to then take an action on, that actually you don't need that much, which also has benefits for the radio technology you're using. You can use a a smaller data pipe.
Absolutely, you could get
wide
that
area.
into devices that have got much more humble resources, if you will.
So,
Right. Any questions from the audience? Yes. Oh, there we go. Thank you, Vincent.
So I really enjoyed the conversation. Thanks, guys. Wanted to ask, you've been talking a lot about standardization and the sort of security implications of standardization and the impact that's having on product design decisions. Curious on how you see regulation as, Cyber Resilience Act being the obvious one that everyone's talking about. How's that going to influence those kind of decisions, and how's that going to cross over with some of the standardization pieces that you've been talking about?
Oh, okay. And now we've done the swap we were supposed to do. Sorry. Generally, standardization is the industry innovation is ahead of the standardization, is ahead of the regulation, in my eyes. So regulation is good. It raises all the boats, but hopefully standardization has already got there, and we see that a lot. And a lot of people are asking us about regulation, and we go, well, the standardization in the GSMA is already coping with that. And then you go one step further, the innovation. A lot of companies are innovating around security. So I think that comes first. Now, what are the real use cases we have? What are the real threats we have? How do you do that in a systematic method? How do you do it systematically in industry? And then you do it in the regulation. So I think it's about raising all the boats. I think in the GSMA there's already a really good stance on security. Not too worried about that, but if you look at IoT, there are still people with default passwords of admin. How do you make sure that doesn't even play in the industry? So to me, it's more of the sweeping up the laggards, if you will. Hopefully, the innovation is where the leading edge of innovation is in security. Then making sure it all works together in standardization, and then you look at the regulation. Anybody disagree?
Yeah.
Agree. I think it's also the point that was made earlier, right? Like 5 years ago, perhaps there was a little bit of this, security was an afterthought. Now, with the way things are going, with how much data resides on devices, as well as kind of on the edge, and really kind of utilizes the personal data as well as mission critical data. It's almost that regulations trying to make sure that there are the right practices. There are all these strategies built in already in standardization that can then actually really get to a much wider set of devices. So fantastic question.
I would just add that I think the quirks come in with perhaps more industry-specific regulation than the CRA. So as you say, the CRA itself raises all boats. Where things become a bit more complex is where it's niche and the specific requirements of specific end markets. So that's where you need a bit more flexibility and a bit more particularly design time. That's the element of that complex ecosystem that I was talking about, and why people are leaning towards more pre-certification and more pre-built options.
Yeah, as you're right. There are regulations coming in smart metering, in other tracking devices and things of that. But it's the nature of trying to make sure that these are all more robustly built, and the security is not an afterthought; is built right from the beginning. Brilliant. We are on time here, and I suspect a lot of you wanting to close this show. But if there are any burning questions in your mind, please stay back. Our panel is available for additional questions. I'll be hovering about as well. But thank you so much for joining us today. Thank you to my panel for such insightful discussion. We haven't had any somebody walks into a bar punchline, so I think we'll just have to leave that for your delayed responses on LinkedIn. If you don't already follow us, please do follow Kigen at LinkedIn. We generally run our very geeky conversations as the future of SIM, and that's a hashtag you can always land us back on. Brilliant. Thank you very much, and thank you, Hardware Pioneers.